Okay, so today we're going to look at visible fractions, making fraction addition and subtraction visible, pictures you can look at and see how these methods actually work. So visible fractions, you may have studied fractions before at school, and hopefully this will help you see exactly how they work. I'm going to zoom in so I can use the squares on my paper a little bit more effectively. Just like that, we're going to do some examples, and I'll be asking you to pause your video as we go to have a go at some questions, and I'll show you some solutions. Let's see how we go with visible fractions. So let's try an example to start with. Let's go for 2/7 plus 1/7. Now you'll notice that the denominator is the same in these two fractions. So a bit of language again there. Numerator is the number on the top of a fraction, and denominator is the number on the bottom of a fraction. You'll notice these have the same denominator. We call them a common, meaning the same, common denominator. And you'll probably come across that phrase quite a lot in your mathematics in high school. So 2/7 plus 1/7. How do we make this visible? I will show you now. What we're going to do is just make a rectangle or a lozenge that's 7 squares in size. 1, 2, 3, 4, 5, 6, 7. That's just a little bit low on my diagram, so on my page, so I'm going to make it a bit higher up there like that. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 long, like a lozenge or a rectangle with 7 parts to it, like that. And I'll make another one, another rectangle or lozenge, which is 7 squares long. If you've got squared paper or squared paper in a maths book or a paper, this is how you can go about adding fractions visibly. Now there's 7 sections here, 1, 2, 3, 4, 5, 6, 7. Some people like to think of this as like a chocolate bar with, 7 squares of chocolate in a chocolate bar. That's okay. You can think of it however you wish. Now let's color in 2 of those 7 parts. There's 2 of those 7 parts. In fact, I've just remembered I've got a nice little neat tool here. I can use my markup here and we'll shade in 2 of those 7 parts. There we go. And over here we'll shade in 1 because it's 1/7. So I've got 2 out of 7, 2/7 plus 1/7. I'm adding these together. What will I end up with? How much will I end up with? So again, we can just draw a nice lozenge or rectangle. It's 7 squares. How many out of 7 do we have? Well, we have in total 1, 2, 3 squares shaded. So overall, I'm going to end up with 3/7. Didn't quite get that one on, did I? Let me just do that again. I'm going to end up with 3/7. So 2/7 plus 1/7 is 3/7. And you'll notice that we can just add the numerators, but the denominator remains the same when adding and subtracting fractions or adding fractions. Okay, so that's why 2/7 plus 1/7 is 3/7. A common mistake is to add the denominators as well, but hopefully you can see that 2 out of 7 plus 1 out of 7 is 3/7. Okay, let's have a look at another example, maybe a subtraction this time. Should we do any subtraction this time? With the common denominator, the same denominator, we'll do a subtraction. What should we do? How about this? Let's do 5/8 subtract 3/8. Again, we have a common denominator. So I think I can make my visual fraction quite nicely. I'll go to my shapes, my rectangles. I'll do a similar thing. I'm going to make a lozenge or a rectangle, which is 8 long this time. 1, 2, 3, 4, 5, 6, 7, 8, because these fractions are out of 8 parts. And here, let's just try and start right at the top there. There we go. 8 parts. Now, I've seen people try and do things with pizzas before, and that's fine, fractions of pizzas, but I think visibly it's a little more straightforward if we use squares and lozenges and rectangles like this. Okay, so we've got 5 out of 8, subtract 3 out of 8. So let's do some drawing here. And if you're doing these drawings in your books or on paper, on square paper, you can just do some coloring here. It's quite mindful just to do some coloring. I'm going to color in 5 out of those 8 squares, 1, 2, 3, 4, 5. And then 3/8 is 3 out of these. Oops, Daisy just missed off there. There we go. 3 out of 8 missed. I've just got it right there. And I'm doing a subtraction this time. We're subtracting. So I've got 5 squares shaded out of 8 here. I've got 3 squares shaded out of 8 here, and I'm subtracting. What will that be equal to? So we'll just do our visible fractions again. We'll do a rectangle. You'll notice I'm using this word lozenge. I do like that word. Lozenge has usually got a bit of rounded corners, but I'm going to keep using that word now and again. A rectangle there, out of 8 parts, 5 take away 3, or 5 subtract 3. Yeah, you've got it. It's going to be 2. So the answer here will be 2. 5 of those squares, again, if you want to think of them as chocolate bar squares, 5 out of 8, take away 3 out of 8, we're left with 2 out of 8. So there we go. There's a visible way of looking at adding and subtracting fractions. Now, sometimes you look at 2 out of 8 and you think, oh, hang on a minute, because sometimes you're told to write fractions in their simplest form. In other words, the simplest numbers in the numerator and denominator. And you might spot that 2/8 could be written in a simpler form. So we're going to write 2/8 as a simpler form. Now, if fractions will have the equivalent value, so equivalent fractions have the same value, numerical value, and as long as we multiply or divide the numerator and the denominator by the same number, we will end up with fractions of the same value. And here you can spot, hopefully, that if we divide this by 2 and divide this by 2, we will end up with the same equivalent fraction in its simplest form, 1/4. So such a language-rich subject, mathematics. We've got numerator, denominator, common denominator, simplest form, equivalent fractions, all of this language. It's hugely important that you understand and can use the language of mathematics. So 5/8 subtract 3/8 is 2/8, which is the same as a quarter. Why is it the same as a quarter? Well, look, let's be visible. Have a look at this 2 out of 8 here, 2/8. I can draw and break this rectangle up into 4 equal parts. Excuse me. 4 equal parts. How many of those are shaded? One of those 4 equal parts. So that's 1/4. So 2/8 is the same as 1/4. And again, in visible fractions, you can see why those equivalent fractions are exactly the same. 2/8 is the same as 1/4. Overall, 5/8 minus 3/8 is 2/8. If we have this common denominator, we can simply think of fractions, visible fractions, by making these rectangles of the same size using squared paper, shading in how many we've got of each, deciding if we're adding or subtracting, and then working out the answer and possibly simplifying if we have a common denominator. Now, if we don't have a common denominator, if we do not have a common denominator, things can get a little trickier. So we're going to have a little look now at a situation where you may have 2 fractions which are being asked to add or subtract, but there is not a common denominator. So there's no common denominator. Let's have a look at an example like that and see if we can still use visible fractions to add and subtract the fractions. I'll do one of the more classic examples of fractions. Here we go. We're going to add 1/2, 1/2, and 1/3. You might notice that the numerators are the same here. So maybe I shouldn't cause confusion. What I'm going to do maybe is give you 2 fractions which don't have that fact. So I'm going to give you 2/5 plus 1/3, just so there's no confusion that this will work for any situation, not just the situations where the numerators are the same. So here we go, 2/5 and 1/3. Now, you'll notice straight away we do not have a common denominator. And if we try to use the same visible fractions method, if I make a bar, like a rectangle, out of 5 and a rectangle out of 3, well, how do I combine these two? Well, I don't know. I'm not really sure. What's the denominator going to be? Look, I could shade in 2/5 of this one. There's 2/5 of this one. And there's 1/3 of this one. And you might think, well, I've got 3 squares. So yeah, if I'm adding them together, I've got 3 squares. So I've got 3 squares, but well, how big do I draw my rectangle? I'm adding 2 different kind of rectangles here. Look, this one's out of 5 and this one's out of 3. Well, that's not fair. That fraction there isn't the same out of, is it? It's not the same denominator. It's just not kind of fair. So that doesn't seem to work at all. So we need to change it up. Let's change it up. If we've got a different denominator, our visible fractions, we have to be a bit cleverer here. Let's try. I'll show you what to do. What you do is you look at the denominators, 5 and 3. 5 and 3. And you can draw a rectangle which is 5 by 3. That's not a rectangle, it's 5 by 3. I'll try that again. We're going to draw a rectangle that's 5 by 3. So the denominators are 5 and 3. So I'm going to draw a rectangle that's 5 by 3. 1, 2, 3, 4, 5 by 3. There we are, 5 by 3. In fact, I might go that way around, 3 by 5, because I think it'd just be a bit easier to fit on my page of working. There we are, 5 down and 3 across. 5 down and 3 across. And then I'm going to be working with the same type of rectangle. So there's another one, the same size. And I'm going to use these to find the sum of these two fractions, and my answer will be a fraction out of the same size rectangle. Right, that seems fairer now. So let's have a look what we can do. I'm going to be adding, and I want it to be equal to. So I've got to shade 2/5. I've got to shade in 2/5 of this rectangle. How do I shade in 2/5 of this rectangle? And I'm sure you've done some questions like this before. But if we look, there are 5 rows. There are 1, 2, 3, 4, 5 rows. So 2 out of 5. Shall I make that a little clearer for you? Shall I do some lines here, which will show that this has 5 rows. Look, there's 1, 2, 3, 4, 5 rows. There's no surprise that we chose it that way. And this one has 3 columns, which is going to really help us shade a third. 1, 2, 3. There we go. So I want to shade 2 out of 5 of this rectangle. So I can do that, I think. 2 out of 5 of this rectangle. Here we go. I'll shade 2 out of 5 of this rectangle. There we are. And I want to shade 1 out of 3, 1/3 of this rectangle. But now, of course, because they're the same size, rectangle, it seems fair that I can add these now. Now, you can still keep that kind of chocolate bar analogy if you wish to, because chocolate bars sometimes come in rectangles, don't they? And you break squares off and gobble them up, the delicious chocolate. But we can keep that chocolate kind of analogy if we wish to. But now we can just add. Look, I've got how many squares when I add them together? I've got 1, 2, 3, 4, 5, 6 here. I've got 6 here, and I've got 1, 2, 3, 4, 5 here. Well, that makes 11. That's 11 squares altogether. 1, 2, 3, 4, 5. Should I just count them with you now, just to make sure we get the right number? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of those squares will be shaded. So I just need to shade 11 of these. I don't think it matters which ones I shade, I should say. But let's shade 11. I'm going to shade those 9 there and 2 more. So I've got to shade 11 of these squares when I add them together. There'd be an overlap if I tried to draw the same thing. You can see I count the same thing twice if I just tried to lay one on top of the other. So I've got to kind of do it in that way. But there's 11. There's 11 squares there. We'll check 1, 2. Oh dear, that's not checking at all, is it? Let me just do that again. Drawing. Here we go. Check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes, I've not missed any out. And so my fractions added together, my visible fractions, the answer is 11 out of, oh, how many altogether? How many altogether? Did we forget that? We didn't. Did we forget to work that out? Well, hopefully you know how many squares there will be altogether without having to count them each individually, because there's 3 squares that way, and there's a bit of a wobbly line there, 5 squares that way. So how many squares are there in total? There's 3 times 5 is 15 squares in total. So that's 11 out of 15. That's 11 out of 15 that we've shaded. And so we didn't have a common denominator. We haven't used a kind of numerical method here to add these 2 fractions. We've drawn pictures. These are visible fractions. And if you're beginning high school and you're not sure about how to work with fractions, this is a great way of starting. You can learn those numerical methods once it's really, really solid in your mind about what's happening on and secure in your mind of what's going on with these fractions. So it's a great, great way to do it when you're starting in secondary school. So there's our answer, 11 over 15. Some of you may know numerical ways of doing it, but maybe you haven't ever really understood what those numerical methods are doing, why you multiply 3 by 5 to find a common denominator, etc. But this is a great visual to help and support you. So I'm going to write one up now, and I'm going to ask you to pause the video and have a go at doing it yourself, okay? Have a go at doing this one yourself. We'll do, what should we do? Should we do, let's go for 3/7. And should we take away a quarter? Should we do 3/7? This time subtracting. Don't forget you're subtracting here, not adding. So let's see if you can do some lovely diagrams. If that's enough for you, pause immediately and have a good go at that. See what answer you get. Don't draw them out. If you haven't got squared paper, don't worry, just draw out a representation of it. You can use a ruler if you want to, or just a quick sketch, and try and get the answer to that one. So pause the video now, and in a moment you can play again and I'll go through the answers. Okay, so if you were not quite sure, you might want an extra little tip, but if you've done it already, that's great. I'm just going to give you the answers now, but I'll give you an extra tip here. So it's 7 and 4 the denominators, and as above, I'm going to create 2 rectangles that are 4 and 1, 2, 3, 4, 5, 6, 7. 4 and 7 will be the dimensions of my rectangle. The dimensions of my rectangle will be 4 and 7. Okay, so I've used that word dimensions. What does that mean? Let me just write that word down. I'm trying to keep a track of all these words I'm using. Such a language-rich subject. Dimensions kind of means length, width, etc. So just trying to keep track of all that language I'm using. So dimensions means length or width. So the dimensions of my rectangle are 4 and 7, these the denominators of these fractions. They don't have a common denominator. So we can't just do those simple rectangles, which are just the number of squares is the denominator. We have to use this clever method here. We're doing a subtraction, and we're hopefully going to end up with an answer, which I can still use this 4 by 7. That's the phrase we use, 4 by 7 rectangle. There we go. So let's see whether, now if that's enough of a tip for you, again, pause the video, do your shading, see if you can work out what 3/7 subtract quarter is. See if you can work that out. If not, here we go. Or if you've done your answer, you've done your solution and you just want my answer, here we go. What I'll do is I will split these up to really help you. There are 7 bars across here. 1, 2, 3, 4, 5, 6, and 7. So 1, 2, 3, 4, 5, 6, 7. No surprise, we chose it that way. There are 4. That's a little off. I'm going to change that one. Columns. That's a little off as well. Let me see how many times it's going to take me to get this right. I'll do that time. That's good. Try and be accurate if you can be. There are 4 columns. Again, there's no surprise there's 4 columns. We chose it this way. We chose these rectangles this way, but you don't have to draw these lines in if you're okay and you're secure with shading fractions of rectangles or fractions of shapes. You don't have to draw these lines in. This is just to help it if you're not quite secure in this shading. 3 7 says 1, 2, 3, 4, 5, 6, 7. I need to shade 3 of them. So here we go. I'm going to shade 3 of them. I tend to always shade the ones at the bottom, but it doesn't actually matter which ones you shade. I could shade the 3 at the top. It's just a representation visually. 3 7ths there, and a quarter here. And again, I usually just shade the one on the left, but it could be any one of those 4. There we are. So very well done if you got that bit right. 3 7ths plus 1 quarter. And then we have to work out, what that fraction, when we add these two, what's it worth? What's it worth? We're comparing the same size rectangle, so it's absolutely fine. We're doing well here. Really good. Let's do the counting. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. No, you're right. I've got it wrong. Why have I got it wrong? We're subtracting. Oops, daisy. So if you made that mistake that I just made there, stop the video now and put it right. There we go. So how many here? There was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And here there's 1, 2, 3, 4, 5, 6, 7. Now, if we want to think about it, what we're doing here, now you may have realized this, some of you who know these techniques. Here we've got 12 out of a possible 28. Where's that 28 come from? Well, it's come from the same thing there, isn't it? That's 7, and that's 4. So how many squares do I have altogether? I have 4 times 7. Oops. I have 4 times 7, which is 28. I have 4 times 7, 28 squares altogether. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 out of 28. Here I've got 1, 2, 3, 4, 5, 6, 7. I've got 7 out of 28. And I'm doing a subtraction. So I had 12 squares here. I'm subtracting 7. So how many do I need to shade? I'm going to shade 12 take away 7 is 5. I'm just going to shade 5 of them. Any 5 will do, but I'm going to shade 5 of them. 12 squares take away 7 squares, or subtract 7 squares is 5. So my answer is 5 out of a possible 28. You see? Now, these fractions down here, which I didn't include above, but I can go back and show you in just a moment. These fractions here are, going back to that very beginning thing I said, they are equivalent fractions. 3 7ths is equivalent to 12 over 28, multiplying the numerator and denominator by 4. 1 quarter is the same as or equivalent to 7 over 28, multiplying numerator and denominator by 7. So we can create fractions with a common denominator. But at the moment, we don't have to do this here. This is an option. You can just draw the pictures, and the pictures show you the answer. The pictures show you the answers. But yes, for some of you who've done this working before, now you're making the connections and links and security of knowledge that there's a reason why changing to common denominators and adding the fractions works. And this is that representation there. Okay, so above, if you use the common denominator approach, 2/5 would be the same as 6 out of 15. And here, 1/3 would be the same as 5 out of 15. But you don't have to use this common denominator approach. You can just do the visible fractions, okay, the visibles. All right, so if this bit down here that I've shaded in yellow isn't quite there for you yet, don't worry, just do these pictures. Okay, do these pictures. So I think we'll just do one more. We'll do one more as an example, and then if you've got some questions to do from your teacher or in class, or you're homeschooling and you want to do some extra work, you can find some fractions questions, adding and subtracting fractions, and test yourself. But I'll do one more example with you. What shall we do this time? Let's go for, I don't know. What should we do? Let's go for oh dear, I'm still on there. Let's go for something that might end up a little bit different in the answer. Let's go for 2/3 plus, few sevenths. Did we use sevenths already? Yes. Let's go for 2/3. I've used 3/7 as well, haven't I? Let's go for 2/3 plus a seventh. Did I use a seventh already? No, I've got 3/7 there. Got 8, so no, we'll go with that. 2/3 plus a seventh. Okay, now I'm going to go for a little bit more than that. Let's go for a little bit more than that. Let's go for 5/7. Ooh, yeah, let's go for that. 2/3 plus 5/7. If you think you can do it, go for it. Pause the video. So I'm going to go a bit quicker through this one. Here we go. We're going to create a rectangle which is 3 by 7. 1, 2, 3, 4, 5, 6, 7. Another rectangle that's 3 by 7. 1, 2, 3, 4, 5, 6, 7. And we're going to have answers which are 1, 2, 3, 4, 5, 6, 7. Okay, let's have a go with this. Let's put the plus sign in. Let's do that. We're adding today. 2/3. I won't do all the breaking up into the strips or the columns and rows. Hopefully you can have a good go at that. But 2 out of 3 of the columns. There we go. 2 out of 3 of the columns. Yeah, it doesn't matter which way around we orient the rectangle. I've done it this way because it fits in my screen a lot better. I could do it around the other way, and 7 long and 3. It's just the way it fits in. So 2/3 there for the rectangle. 5/7 here. So there's 5 rows, and 7 rows, and I'm going to shade in 5 of them. 1, 2, 3, 4, 5. How many overall does that give me? Let's add them up. Let's go in there. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm adding, so 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. 29. 29. 29. I've only got 3. Oh dear, that's really 29. Okay, I give up trying to do that by hand. But I've only got. Fourth time lucky. I've only got 21, I think, haven't I? How many are there? 3 times 7 is 21. But I've got to shade 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 29. How do I shade 29? How on earth do I shade 29? I've got 21 there, but I want 29. And of course, what we have to do is have another rectangle, because we've got more than a whole one here. We've got more than a whole. 2/3 plus 5/7 will be more than a whole. So I will now have to create another rectangle of 3 by 7. So we're comparing the same thing. I've got 21 shaded there, but I wanted 20. I'm going again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 29. I've got 21. I want 8 more. So now I've got to go back in and shade 8 more. Well, there's 7 more. And there's 8 more. So what's my answer? What's my answer? Well, my answer is that I've got one whole one, and I've got 1, 2, 3, 4, 5, 6, 7, 8 out of 21. As a mixed number, I've got one whole one and 8 out of 21. The other way you could write it, if you want to, is consider it as an improper fraction. I've got 29 out of 21, and that's an improper fraction. Another amazing bit of language richness for you, improper fraction. So you can write things as improper fractions or as mixed numbers. Mixed numbers, whole parts and fraction parts. Improper fractions, where the numerator is larger than the denominator. And that's a whole nother video, I suppose, reminding you how to change between the two. But here you can see you've got one whole one and 8 out of 21. And I hope that is better, or is good for you to secure that knowledge of how you add fractions with the same denominator and how you add fractions with different denominators. And you can use this visible method of using rectangles and shading to really, really help you. Thank you for watching and taking part.